Right now on this planet, there are over 8 billion people. Cities stacked on cities. Airports full of strangers who will never meet, speaking languages neither of them could ever learn fast enough to understand each other. And somewhere in your bloodline, a few thousand years back, that entire population was small enough to fit inside a single stadium, not a metaphor. A real number sitting in your own DNA right now, waiting to be read. Here's the question that should bother you. If there were really that few of us, why aren't you stranger? Why do you look roughly like the person sitting next to you on a train and not like something bred in a bottleneck? Thin, fragile, half-formed, the way small isolated populations usually turn out? You're about to find out how close the whole species came to not making it here at all. Think about what almost dying out actually means for a species. It's not a movie ending. There's no dramatic final scene, no single moment anyone could point to and say, this is when it almost ended. It's quieter than that and worse. A population that shrinks past a certain point doesn't just lose people, it loses options. It loses the genetic backup copies that let a species absorb a new disease, a new predator, a new twist of bad luck it hasn't faced before. You carry the echo of that shrinkage today, whether you know it or not. Every human being alive, no matter where they were born, shares a genetic similarity to each other that's almost eerie once you see it laid out next to any other species. Chimpanzees living in a single forest in West Africa carry more genetic variation among themselves than the entire human race does, spread across every continent, every climate, every corner of the earth. Stop and sit with that for a second. Your species is the least genetically diverse great ape alive. And that's not because we're special. It's because at some point, we were almost erased. Geneticist Rebecca can trace human mitochondrial DNA back through generation after generation, following the maternal line like a thread pulled through time, watching where it led. It didn't fan out the way you'd expect from a species that had always been large and spread out and comfortably established. It funneled down hard toward a single narrow point, a bottleneck. And bottlenecks in biology only mean one thing, something pushed the population down to almost nothing, and everyone alive today descends from whoever happened to survive. So what did it? What almost finished us off before we'd even really started? Around 74,000 years ago, a volcano called Toba on the island of Sumatra didn't just erupt, it detonated. Anthropologist Stanley Ambrose has argued this wasn't a normal eruption at all. It was one of the largest volcanic events of the last 2 million years, throwing enough ash and sulfur into the sky to choke out sunlight across entire continents at once. Picture this. The sky doesn't just get cloudy. It goes dim for years, maybe as long as a decade. Crops that don't exist yet can't fail, obviously, but the wild plants and animals early humans depended on for every single meal start dying anyway, on a timeline measured in seasons, not centuries. A volcanic winter like that doesn't ask who deserves to survive. It just removes the margin. Food thins out fast. Small bands that were already scattered thin across the landscape get pushed even further apart from each other, hunting the same shrinking resources. And here's the part that makes it worse. Once a population drops below a certain size, it doesn't need a second disaster to finish the job. Small numbers alone become the danger. Fewer people means fewer chances for a lucky, useful mutation to appear anywhere in the group. Fewer people means one bad flu season, one bad drought, one difficult winter of childbirth complications can tip the whole thing over into nothing. Here's where it gets strange. Some researchers estimate the surviving human population may have dropped to somewhere between 3,000 and 10,000 breeding adults. Not villages scattered across a continent. Not regions. A number small enough that if you gathered every single ancestor of every human alive today into one place, they might not have filled a modern sports arena. You are not descended from thriving, spread out ancestors comfortably running the planet. You're descended from the tight, lucky remainder that made it through a global filter almost nobody was supposed to survive. That number should feel impossible. It doesn't match the world you live in now, full of nations and languages and 8 billion competing lives crammed onto every continent. So hold on to that discomfort because it's about to get worse before it gets better. If the population really dropped that low, the math should have broken us permanently. Small, isolated groups, cut off from each other by a dying, ash-choked world, should have drifted apart genetically over the following thousands of years. Different pockets of survivors, different mutations building up in isolation, different evolutionary paths forward. That's what should have happened. That's what happens to almost every species that goes through a bottleneck this severe. They come out the other side fractured, split into distinct, divergent branches that barely resemble each other a few thousand generations later. That's not what happened to us. Here's the counterintuitive part, the part that should genuinely unsettle you. Even at 3,000 breeding adults, even scattered across a starving, darkened landscape, humans didn't fracture into separate, drifting subpopulations the way genetics alone would predict. Something kept the surviving pockets connected to each other across the wreckage. Something kept the gene pool from splintering into isolated island populations, each one quietly evolving in its own separate direction, the way it should have. Population geneticist Henry Harpending has pointed to a quieter explanation, one that has nothing to do with luck and everything to do with what makes humans different from every other species that's ever faced a bottleneck like this. We talk, we trade, we move even under pressure, especially under pressure, even in near starvation conditions. Scattered bands of early humans apparently stayed in loose contact with each other, trading partners across long distances, exchanging mates across group lines, passing information hand to hand about where the food still was, where the water hadn't dried up yet. A gorilla population cut down to a few thousand individual splinters permanently along whatever lines happened to separate the survivors. A human population cut down to the same size apparently kept finding a way back to each other. That's the twist underneath the twist. The thing that nearly killed the species, isolation, scarcity, catastrophe, is also the exact condition that should have permanently split us apart into separate lineages. And it didn't, because cooperation turned out to be a survival trait every bit as real and as measurable as any physical adaptation, like an opposable thumb or an upright spine. You didn't just inherit thin genetic diversity from that bottleneck. You inherited a species that survived specifically because it refused to stay isolated, even while it was dying. Now widen it out, because this isn't just an ancient story sealed off behind 4,000 years of distance. This is the exact same genetic thinness sitting inside you right now, in this exact moment. Every human immune system on Earth is working with a narrow genetic toolkit than it would have had if that bottleneck had never happened. That's part of why a single virus can spread through the entire species with such devastating speed and reach. There's less natural variation standing between a pathogen and a population that genetically is closer to a single extended family than most people are ever comfortable admitting out loud. Compare a wild population of cheetahs, which went through their own severe bottleneck thousands of years ago, and you'll see the exact same signature written into their biology. Skin grafts between completely unrelated cheetahs succeed almost like they're transplants between siblings because the genetic variation just isn't there anymore to reject them. Humans aren't quite that extreme, but the shadow of the same kind of event is written into why one disease can threaten billions of us at once, instead of being naturally blocked by the sheer genetic variety a larger, older, less squeezed population would have carried. Geneticist Svante Pääbo, working from ancient DNA rather than living samples, has shown that this thinness isn't limited to one line of evidence either. It shows up again and again in nuclear DNA, in Y chromosome DNA, in every independent method scientists have used to check Rebecca Cahn's original finding. That's not a coincidence, and it's not a data error waiting to be corrected. Multiple unrelated lines of evidence pointing at the same narrow bottleneck means the near extinction wasn't a theory that got lucky once. It's one of the most consistently confirmed events in the entire human genetic record. The civilizational stakes are bigger than any one outbreak, though. Every language you've ever heard, every nation, every war, every migration story ever told, all of it happened after the bottleneck. All of it was built generation by generation by the descendants of a group small enough to nearly vanish completely off the face of the planet. The entire sweep of human history, every empire and invention and quiet ordinary life lived in between, is the aftermath of a near miss so narrow that a slightly worse eruption, a slightly colder decade, a slightly less cooperative set of survivors, and none of it happens. Not you, not this video, not the language you're thinking in right now as you listen to this. Here's the part that actually changes how you should look at the world today. Modern humans still show that same instinct from the bottleneck. The pull towards staying connected even under pressure, the exact trait Harpending pointed to in those scattered post-Toba survivor bands thousands of generations ago. You see it now in disaster zones, where isolated communities that have every practical reason to turn inward and protect only their own instead pool resources with total strangers. You see it in the sheer scale of modern trade and migration, an exaggerated planet-sized version of exactly what those first few thousand survivors were doing out of raw necessity just to keep the gene pool and the species itself from splitting apart for good. So the next time a room feels crowded or a city feels like too many people crammed into too little space, remember what you're actually looking at. Not overcrowding, recovery. 8 billion people, all descended from a population so small it should have ended everything, all still running on the same ancient instinct that pulled the last few thousand of us back from the edge. The instinct to find each other instead of drifting apart.